Hey there, let's start talking about some other representations of trig functions, and this is something called sum and difference identities. One of the reasons why you might need to use this is, for example, if they asked you to find what's the sine of a 75-degree angle. You know this, but the most common angles we have around the unit circle are 30, 45, and 60. We don't have a 75, but I could break this up into and say, well, I know the values of 30 and 45. So because I know these values better than 75, I need to figure out a way that I can use this, what I know, to find what I don't know. So this is where the sum and difference identities come in. So here we go. Sine of some unknown angle alpha and some unknown angle beta. So these are two different angles, okay? These are two different angles. So sine of alpha plus beta is the equivalent of sine alpha times the sine, times the cosine of beta plus sine of beta times the cosine of alpha. Okay, so the sine of the first angle times the cosine of the second angle plus the sine of the second angle times the cosine of the first angle. Same thing goes for here for sine of alpha minus beta. Keep in mind a really important part here is what's happening. Are they adding or subtracting? So this is kind of similar. We still have the same order of things, sine alpha, cosine beta, but instead of adding, you might expect something different because this is subtraction. We're going to subtract the sine of beta times the cosine of alpha. Okay, so very, very similar identities. The difference is if it's an addition in the equation, and if it's a subtraction in the equation as well. All right, let's look at cosine. So same thing here. So we've got our different angles, alpha and beta. Cosine slightly different. So cosine means that we're going to take the cosine of the first angle times the cosine of the second angle. But with cosine, even though since these two are next to each other, we're going to take the opposite of the sign in the middle. So this is, if this is a sum, we're going to find the difference here. And we're going to find the sine of the first times the sine of the second. Okay, and then same thing goes for the cosine of the difference. So same idea, cosine alpha times the cosine of beta, but instead of subtraction, we're going to use the opposite, which is addition. And then sine of alpha times the sine of beta, the second angle. So let's use these in practice and find the exact, remember exact means no calculator, of the sum or the difference of this. So this here, this is my alpha, my first angle. This here is beta, and I'm going to notice what's happening in here. I know this is a sum. So since this is a sine sum, I'm going to be using this one right here. So I'm going to pre-write it out. I know sine of the first times cosine of the second plus sine of the second times cosine of the first. And now I'm going to plug in alpha, which is pi over 4. So we're going to say, okay, sine of pi over 4 times the cosine of the second one, cosine of 5 pi over 3, plus sine of the second angle times the cosine of the first. So as you can see here, we're looking at sine and cosine of these two angles. Okay, so now let's figure out, let's draw out alpha and beta. One of the things that's going to really help you here is to either know the unit circle by heart, or you're going to want to have our cute little reminders. So remember here, we use our sine, cosine, tangent, pi over 6, pi over 4, pi over 3. 1, 2, 3, 3, 2, 1, all over 2. Roots on the top. And then sine divided by cosine. okay, might help you if you have these as well as all students take calc, right? All right, so let's go and use some of this. So remember, I know sine of pi over 4. Well, sine of pi over 4 is right here. So sine pi over 4 is root 2 over 2. And that's in the first quadrant, so I know it's positive. Times the cosine of 5 pi over 3. So actually, really quick, let me go back. Sine of pi over 4, this is alpha. Pi over 4 is right here. We know that's root 2 over 2 comma root 2 over 2. And then 5 pi over 3, I know 5 pi over 3 is right here, right? So if beta is 5 pi over 3, I know that point, cosine comma sine, is here. Cosine of 5 pi over 3 is going to be 1/2 comma root 3 over 2. And we know since it's in the fourth quadrant, x is positive and y is negative. So let's use that. So our cosine of this angle is 1/2. And then I know the sine of 5 pi over 3 is right here, negative root 3 over 2. And the cosine of pi over 4, we know is right here. Sorry, this one, first one, root 2 over 2. And now we're just going to multiply out what we've got, these two. We're going to take root 2 times 1 is root 2 over 2 times 2 is 4. Add, the numerator is multiplied, we get negative root 6 over 4. They both have the same denominator, so we can combine them. So we get root 2 minus root 6. This looks strange to you because you've never seen it before, but you will start to see very similar values, lots of root 2's and root 6's over 4 over and over and over again. All right, let's look at this one. So if we're looking for cosine of 7 pi over 4 minus 2 pi over 3, this is our alpha, this is our beta, and we have a minus in the middle. So we're going to be looking at cosine of a difference. So the difference of cosine is going to be this one right here, okay? So I know cosine alpha, cosine beta, opposite sign, sine alpha, sine beta. So let's now that we've written it down, let's connect these two. Let's sketch this out. So I know alpha, we'll draw it here, and beta, we'll draw it here. We know alpha is 7 pi over 4. That's this right here. Anything pi over 4, remember, is root 2 over 2, root 2 over 2. X is positive, y is negative. And for beta, 2 pi over 3 is in the second quadrant. And we know from this, anything pi over 3 is 1/2 comma root 3 over 2. We know in the second quadrant, x is negative. Okay, now it's just a little reminder, cosine comma sine. So let's go ahead and fill these in. Okay, so let's talk about cosine alpha. It's right here, root 2 over 2, and cosine beta is right here, negative 1/2. Now let's talk about sine alpha. It's right here, negative root 2 over 2, and sine beta is right here, root 3 over 2. Let's simplify what we have. Negative root 2 over 4 plus negative root 6 over 4. Simplify, we have the same denominator. We got negative root 2 minus root 6. Okay, now sometimes we're simplifying something. We can't get it all the way down, but we can simplify it as much as we can. Remember, these are two different thetas, two different angles. We'll call this alpha and beta. This is the subtraction. So we're finding the difference of sine. Remember, difference of sine is sine alpha times the sine of beta minus same sign, sine, oops, I messed it up already. This is cosine. And then sine beta times the cosine of alpha. Okay, so same sign, but remember sine and cosine are mixed up. So we're going to simplify what we have here. And remember, sine alpha is just x, so that's sine of x. Cosine beta, now beta is a specific angle. Beta is pi over 6, that's right here. And in our chart, we know anything pi over 6 is root 3 over 2 comma 1 half. Okay, so I know cosine of beta is root 3 over 2 minus sine beta is 1 half. And cosine alpha is just cosine of x. We can't do very much here. We can just multiply this through. We get root 3 over 2 sine x minus 1 half cosine x. Okay. All right, next page. Now, just like we took sum and differences, sometimes we need to double an angle. One of those cases could be like, let's say we were looking for a specific angle like 15 degrees. Well, I can't tell you the sine or the cosine of 15 degrees, but if I doubled it, like 2 alpha would be 30 degrees, I could tell you the sine and cosine of that value. So this would be one of the reasons why we have to do this. This derives actually from the sum and difference identities, but the value of sine of double an angle is 2 times the sine of the angle and times the cosine of the angle. And then the cosine of twice the angle, there's 3 different ways we could see this. We can see cosine squared alpha minus sine squared alpha. Or a second way is we can see 1 minus 2 sine squared alpha. Or the other way we can see it is 2 times the cosine squared of alpha minus 1. For the cosine 2 alphas, you're going to use these 3 depending on the context of your problem. And you'll see what I mean by that in just a second. So now that we have those double angle properties down, let's go ahead and start to use them. Okay, so use the trig identities to solve within one circle, find exact values. Again, this means no calc. Okay, so to find sine 2x, there's only one of those I can only substitute it for, is 2 sine, instead of alpha, they're using x, times the cosine of x, okay, equals the cosine of x. So if I want to solve this, I'm wanting everything to be on the same side, so I'm going to subtract that cosine x over, put the cosine x's together. So I get 0 equals 2 sine x cosine x minus cosine x. Even though this is really long, I can see that we have a greatest common factor here of both cosine x's. So I'm going to take out the cosine x as a greatest common factor, and I'm left with 2 sine x minus 1. I'm going to use the zero product property here. I know cosine x equals 0, and 2 sine x minus 1 has to equal 0. Well, I know here, okay, cosine x, in order for it to equal 0, I know cosine is the x value. It's got to be here or here because this is at 0, 1, and 0, negative 1. Well, those values of theta are pi over 2 and 3 pi over 2. So x can be those 2 angles within one circle. I'm going to solve the rest of this one. I'm going to add 1 to both sides and then divide the 2. So I end up with sine x equals 1 half. Well, we know, first of all, there's 2 parts to this. Sine is positive. So remember, all students take calc. I know sine being positive means it has to be in the first or the second quadrant. And I know in order for sine to be 1 half, it has to be a pi over 6 in the first quadrant. And then a pi over 6 in the second quadrant from here to here is 5 pi over 6. So I know x is also pi over 6 and 5 pi over 6. All right, let's do the last one here. So again, we're dealing with a cosine 2x. There are 3 options for this. So you're going to choose the one that you think fits the best. So as I'm looking at this, I know I have to relate it to 2 cosine squared. Notice there's no sine here. So if I'm looking at these, this one there's a sine and cosine. This one has just sine. This one has just cosine. Since I'm relating it back to cosine squared, I think this one is the best fit because it's only got cosine in it. So that's the one I'm going to choose. Now remember, anytime you choose the wrong one, you can always go back and change it later. So instead of cosine 2x, I'm going to use this right here, 2 cosine squared x minus 1. And then I'm just bringing down what was already there. And now we can start to simplify. We're going to distribute. So we get 6 cosine squared x minus 3 equals 2 cosine squared x. And now I'm going to solve. I want to get these two cosine squareds together. So let's subtract the cosine squared to this side. This leaves me with 0 on the right side. 6 minus 2 is 4. Total cosine squared x is minus 3. I can just solve this directly because I only am dealing with cosine squared. I'm going to add 3 to both sides. And I've got 4 cosine squared x equals 3. Divide both sides by 4. So I'm dealing with cosine squared x equals positive 3 over 4. Now remember, when I take the square root, it's got to be both plus and minus. So I'm left with cosine squared x equals plus or minus the root of 3 over the root of 4 is just 2, which is a good thing because this is a value that I recognize. Now I have to say, okay, where around the circle do I see that cosine x has to be plus or minus? Well, I remember all students take calc. Well, plus or minus is going to be in every single quadrant. And in order for cosine to be a root 3 over 2, that's a pi over 6. So a pi over 6 in the second quadrant, we know that's 5 pi over 6. A pi over 3 in the third quadrant is 7 pi over 6. And in the fourth quadrant, we know is 11 pi over 6. So x is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, I'll see you guys in class.